Okay, Giorgio, so today we're going to go over the von Neumann model and how the fetch and execute cycle work. So the von Neumann model is the basic requirements for a computer or processing system. It requires a couple different things. It requires a memory unit, a processor, and input and output devices. So the memory unit consists of two different things, the MDR and the MAR. The MDR is the memory address, MDR is the memory data register, and MAR is the memory address register. These registers are the places in which code are found. So in a memory unit, which is the von Neumann model, okay, in each code would consist of two different lines. Would consist of the consist of the address and the code. So what the MAR is the place where we can find the code, the memory address register, and the MDR is the data which is in that code. So for example, if we send a write command to the address 111511003, okay, and we give it the data something something, okay, the place where we will find the location is the MAR, and the place where the data will be found changed will be the MDR. That's all we need to know about the memory units. Okay, the next part is the processor, control units, and input devices. The processor consists of the ALU, the arithmetic and logical unit, which is just like your NVIDIA graphics processor. So if you give it code, math, whatever to do, it will do it for you. That's what our processor unit does. Your control unit is sort of like a list of things which your computer needs to do. It consists of your program counter and your current instruction register. This will be useful in the fetch and execute cycle. So in the fetch and execute cycle, what a computer first does is it fetches data from the MAR, the memory address register, so it knows where to get the data from, and it finds that data and puts it into the MDR, which is the memory data register. So this is what the fetch and execute cycle is. In a program counter, which is sort of the list of things which your computer needs to do, the next instruction fetched from the MAR and stored in the CIR is to be completed by the ALU. So that means in the fetch and execute cycle, your system will take your next action, okay, from your processor, from your program counter. So that list of things your computer needs to do, it'll take the next action which it needs to do. For example, your first thing your computer needs to do is turn on. So while your computer is turning on, okay, your program counter will queue the next action, which will be, for example, load drivers. So while your computer is turning on, your computer is getting ready to load drivers after that. So pretty much the fetch and execute cycle is putting everything in order. So it's telling, okay, after you finish this, you do this, then this, then this, then that. And the execute part of the cycle is just to execute the code which you have gotten from the MDR, the memory data register. So like to put this in better ways, your computer gets code from the MAR, which is your memory access register, your memory address register. So it goes to these different places and gets code and puts it into a list. Says first you do this, then this, then this, and then this and this. and those are just different locations, and each of those locations points to different code, which is their data. And what your execute cycle does is it executes that data. It goes to that, your execute cycle goes to that place and runs the code. That's all your execute cycle is. And when it's done with one code, it goes to the next code and next code and next code. So that's pretty much how your von Neumann model and fetch and execute cycle is. Oh, and also your von Neumann model consists of input and output devices. Just to reiterate, the von Neumann model is anything, the minimum things that a computer needs to run. Bye-bye.